All right, Unit 5, Lesson 10. The images show the same number of coins arranged in different ways. So here we have a straight up and down cylinder with the same number of coins as this cylinder is that's slanted, but the exact same height. All right, our radius is the same because they're quarters. They're quarters. And our heights are the same. So if we were to calculate the volume, it's the same. Okay, it's pretty cool. How are the two coin stacks different from each other? One is slanted. Does either stack of coins resemble a geometric solid? Okay, a cylinder, the left or A is a little bit closer to an actual cylinder than B, although B is still a cylinder. How do the heights of the two stacks compare? They are the same. How do the volumes of the two stacks compare? Explain your reasoning. Well, I already did that. Because they have the same radius, because they're both quarters, and the same height, because we've put the same number of quarters in each stack, the volumes are going to be exactly the same. All right. Here we have the same thing with rectangular prisms. The bases of the prisms are congruent. All right, so just like the quarters, these are congruent. Each base has an area of B square units, and they're the same height. A plane intersects the two prisms parallel to their bases, creating cross sections. Sketch the two cross sections. How do their shapes and areas compare to each other? The shapes are actually congruent. Therefore, the areas are congruent. And I'm going to go get that applet so we can look at it. Okay, be right back. Okay, now this applet is actually it's in your curriculum. You have a link to this. So I've got the bases. I can skew one of these. And I can move that plane up and down. And I've got the exact same shape and same area. All right, separate them a little bit, show the skewness. No matter where I go, they're going to be the same. I want to be able to move that base all the way in. This base is still the same, though I haven't changed it. And this one's going to be the same too. If I change the skewness back, it doesn't matter. All right. Right there, it shows them. Pretty much the same. Something happened. I'm not sure what. All right, it's okay. How would the shape or area of the cross sections change if we move the plane up or down? Okay, it doesn't change. That should say same. How do the volumes of the two prisms compare? Same. The volume is really the area of the base, so length times width, which is the area of the base, times height. And we see that the height is not changing for either the skewed prism and the straight up and down prism, so the volumes are not going to change. It's later in the day, I can't spell. Volumes do not change when it's skewed, okay? So really, how we think about volumes of anything is big B times H, where big B is the area of the base. Okay, the area of this base is a circle, so big B is pi r squared. The area of this is a rectangle, so big B equals length times width. So if we only have to remember volume is big B times H, we won't have to memorize any volumes. All right, it's just a rule of thumb. So equal volume. For each pair of solids, decide whether the volumes of the two solids are equal. Explain your reasoning. So for this first one, if we remember that volume is big B times H, we can say that the volume of this one is big B times H, 12 times 6, or 72. And then the volume of this one is length times width times height. I've got the volume of the base is 12 times 6 is also 72. Okay, same thing. Here, big B times H, so the area of this circle is pi r squared, which is 9 pi, times the height, which is 10, so 90 pi. Here, my area of the base is the same, pi r squared, which is 9 pi, but the height here is actually the height from the bottom to the top. It's the vertical height, not the slant height. Like this 10 is the slant height. It's not what we're looking for. Times 7, so that is 63 pi. So no, not the same. Same here. Well, this one's a little harder. The volume here, you have to write this one down, which is 1/3 big B times H. We'll get to Y in a little bit. So 1/3 big B is pi r squared, and H is 5. So I've got pi r squared, 9, 45 divided by 3, 15 pi is my volume. And here, just because it's slanted, my base has not changed, my height has not changed. So I don't even have to calculate the volume. I know they're going to be the same because the base and the height are consistent. So we're good here. Okay, this one, I've got a triangular prism. I'm not sure, but I do know, remember volume is big B times H. We're going to make that the big B. So we know that the area of a triangle is 1/2 base times height, times the height of the prism. So 3 times 4 is 12, half of that is 6, times 5 is 30. And here, got length times width times height, 5 times 6 times 1 is also 30. All right, volume equals big B times H. My H for this one is 5. My H for this one is also 5 because it's a right angle. My big B is going to be like 5 times 5. So I don't even have to know the formula for volume for these two. I know that my B's are congruent and my heights are congruent. So I know the volumes are going to be congruent. And here I've got big B times H and big B times H, but it's not a full cylinder. So I don't even have to calculate it. And I know that the volumes are not consistent. And that's it. Okay, these examples are actually very, very important for your conceptual understanding of volume.